we've studied systems before. We studied systems last chapter. You studied them in Algebra 1. You have maybe only studied ones with lines though before. And today we're going to take a look at, because we're in our chapter on quadratics, what happens when I have a quadratic and a line. In this case, how many times do those things intersect? 2. All right, hopefully you circled that, okay? So if you're given a picture of a graph, or at the beginning of your homework today, I'm going to ask you to graph something, and I'll show you how you can do that on your graphing calculator. If I just asked for how many solutions something has, it's just how many times they meet, okay? And so in this case, I think we probably can see what the ordered pairs are. What does it look like this ordered pair is to you?
2, 5.
It looks like 2, 5 to me as well. So one of the ordered pairs would be 2, 5. What about this one? And 5, 8. That's what it looks like to me as well. Okay, so the main part that I want to emphasize is there's 3 pictures here because there are 3 things that can happen when you have a line and a parabola. One of the things is they could meet in 2 spots, okay? The next thing could also happen. Let's take a look at this. This one intersects how many times? Once. Move that somewhere else. Would you circle the intersection point, please? And would you write it in the box? All right, so to me, this looks like the ordered pair -2, -5. So the second thing that could happen in a linear's line, quadratic is the U, system, is they could meet at 1 spot. And the third thing that can happen is this. What do you think about that? Yeah, what do you think?
I think that on the graph right now, it doesn't show a point in which they intersect. But technically, if that line goes on forever and the quadratic goes on forever in that one direction.
I don't think they will. Here's why. I think that's sometimes the case that we can't see a good window. Do you see this quadratic's heading this way? And this line's... Okay, but...
The line won't change in direction.
What's that? The line won't change direction. If you would continue this down here and this down here, they are going to continue to get further and further and further apart. And going this way... Okay, now, are there some times where we don't see enough of a picture and then that would happen? Yes, but because this is, if we extend those directions, do you see that? How they're traveling away from each other. So, but I appreciate what you're saying. We should definitely make sure we zoom out a lot and look at windows. It is possible, though, that a parabola and a line don't ever meet. And so sometimes there's no solutions. What's that?
From the projector, it looks like it's going forward on my side.
Which way? This way?
Yeah, it looks like it's going forward from the projector, without the line.
So you think these are going to meet?
No, I was just...
You were just saying,
Yeah.
you were explaining what your mistake was.
Perception.
Okay, okay, all right. As long as you understand, we're good. So one of the main things I want you to understand today is that those are the 3 possibilities, okay? So when solving systems, we could get 2, 1, or 0 solutions. It's never going to be anything more than that when we have a line and a quadratic, okay? 2, 1, or 0 is the only possibility. Okay. And in a moment, when we're done with a couple of these, I'm going to show you how at the beginning of the lesson, if I just want you to know how many there are, we're going to just graph that to find out. All right, now, how do we solve these algebraically? So do you remember in chapter 1, we had One thing that started with an S, one thing that started with an E. Who can tell me what it was to solve systems? Substitution and elimination. Very nice job. Okay. When we're solving these systems, the only thing we're going to use is substitution because one of them is going to have an x squared and the other doesn't. So what we're going to do for our step 1 is we are going to set the y equals equations equal to each other. Another way of thinking of that is using substitution. Second step, move everything to one side. Because when we solve quadratics, we have to have a 0 on one side. And the third step is we're going to solve. And the methods we're going to use to solve are quadratic formula, or factoring. Okay, so the solving portion of this is not any different than what we've been doing for days and days and days and days, okay, because you're going to have a quadratic to solve. The only difference is how do we get the quadratic to solve. So let's take a look at our first example, this one right here. Do you see how I have the y equals and the y equals? And so what I'm going to do is, you can think of it as substitution if you want. I am going to take what y equals up here, and I'm going to substitute it in for y down here. In other words, I'm going to take, since these things both are equal to y, and y is the same variable, I can set them equal to each other. So what I have then is x squared plus 3x minus 5 equals x plus 3. So that was my step 1. Once you get to this step, nothing changes from what we did the other day. We have a quadratic. We need a 0, right, on the one side. We're going to need to move the x, and we're going to need to move the 3. So we're going to subtract the x. I'm going to also go ahead and subtract the 3. We have x squared plus 2x minus 8 equals 0. Okay. Let's see here. How do you like to solve equations? You like quadratic formula? Does anybody really like factoring in here? That makes me so sad. All right, let's run it through quadratic formula. And then I'm going to show, okay, let's time it. See how long it takes us. Ready? Set, go. All right, let's do it. Yeah, and then I'm going to show you how you can factor it. Hey, if you like factoring, do factoring. X equals negative b, so we're going to write negative 2 plus or minus square root 2 squared minus 4 times 1 times negative 8 all over 2 times 1. And you know what, you guys, we're not doing these bottom 2 examples, so if you want to, you can just use the room right down there. All right. Maybe this isn't a factorable one. No, it is. Do you guys get 36 in here? Would you give me a thumbs up if that's what you got? Awesome. All right, so we have -2 plus or minus the square root of 36 over 2. Soraya, what's the square root of 36? 6. -2 plus or minus 6 over 2. All right, now, -2 plus 6 is 4. 4 divided by 2 is 2. Wait, what? What? No, 4 plus, did I say 32? It should be 36. Did I say 32?
No, you said 36.
Okay. If I did, I might have said 4 plus 32 because you get the 32 there. It's okay. Sometimes I say things that I don't know. It happens. All right. -8 divided by 2. Did you get -4 and 2? Okay. Now, here's the deal. Do you remember what we were just looking at above? Those are ordered pairs. What do you think we need to do to find the y-coordinate for the ordered pair? Any suggestions? Like, if I was looking at this, these would be ordered pairs where the graphs meet. So how could I, if I know the x's now, how do you think I could find the y's? Plug them in. And look, plug them into the linear one. Why? Because it's going to be easier. Okay? So we're going to plug 2 in. And you get 5. Let's write it as an ordered pair. This meets at 2, 5. Plug -4 in. So that's one of my solutions. Y equals x plus 3. -4 plus 3, I get a -1. So the other ordered pair is -4, -1. So how many times do these meet? 2. Okay, that took us 3 minutes and 12 seconds. It isn't bad. Do you need this up here? Okay, want to see factoring? You don't have to do it, but I'm going to just show you. If you can get good at factoring. Ready, set, go. What multiplies to be -8 adds up to be 2? -4 and 2. Backwards. Right. That took me 25 seconds. I mean, then you have to plug it in. If you can get good, see, am I trying to make my case? Am I winning any of you over? No. Here's the deal, guys. You got to get better at factoring, but quadratic formula does work 100% of the time. So if you can use it pretty easily, then, and you know you have something that's going to work, I get that. All right. Let's try this one. Okay? Now that I showed you one, what do you think we do first? Any ideas? Some of you are starting already. Good. Because y is alone, I'm going to take what this y equals and I'm going to put it in for y down there. That's going to set these two things equal to each other. Some people like to think of it this way. This is the parabola. I want to find when it equals the line. Okay, now, would you move everything to the other side? We got x squared plus 2x plus 11. You with me? Oh, poop. Plus 1. Thanks, Jolly Rancher for you. Equals 0. Oh my gosh, guys. We have to factor this one. I can't. Sorry. What multiplies to be 1 adds up to be 2? X plus 1 times x plus 1, or that's the same as x plus 1 squared, we've learned, right? We call this a double root because there's 2 of them. Set them equal to 0. What does x equal? -1. How many solutions does this have? 1, because it get the same number, okay? All right, let's plug it in. I always like to plug it into the line. It's a little bit easier to work with. We have -10 times -1 minus 13. Do you want to use quadratic formula on that? Sure. Sure. But I couldn't help it. Sorry. Oh, that's a positive 10, isn't it, when I add it? Right? Isn't that a positive 10? 10 minus 13, so that should be a -3. These intersect at one solution, -1, -3. All right, so what would it look like if they didn't intersect? When you were doing quadratic formula, what kind of number would you get under the square root to have no solution? A negative. So if that happens today, that would be the case 3, where the quadratic and the line don't meet, and then you're going to stop right there, and you're going to say there's no real solution. We're not going to find the complex ones. Okay.